Welcome to Rumi Science Blog. I am Rumi, and today I am going to be talking about Chapter 5 in A Brief History of Time by Stephen Hawking. He's a really smart guy. Chapter 5 is called Elementary Particles and the Forces of Nature, and I'm going to start talking about it now. Okay. Since Aristotle's time, people believed that the world could be sliced up into tiny bits and you just keep on going. There'd be no elementary particle. But some people believed that there was an elementary particle and it was indivisible. This argument continued for centuries until in 1905, Einstein discovered something he called Brownian motion. When dust is suspended in liquid, it moves randomly because he thought that the atoms in the water collided with the atoms in the dust. So the atom was the indivisible particle, which he proved. Now, people thought that this atom was not, after all, indivisible, and J.J. Thomson had demonstrated the existence of something called the electron. He had a red-hot filament which gave off electrons in an electric field to a phosphor-coated screen, which, when the electrons crashed into the phosphor-coated screen, flashes of light were created. Now, it wasn't until Einstein proved the existence of atoms that people believed that the electron was coming from the atom itself. And then Ernst and Rutherford proved that the existence of protons, and he said that an atom was made of protons in a nucleus and then orbiting electrons. Next, James Chadwick discovered the existence of the neutron in the atom. So now we know that there are protons and neutrons in the nucleus, and then electrons orbit around it. People then discovered that these neutrons and protons were made of something called the quark. Now, there are 36 types of quarks. They can be anti or normal, and they come in 6 flavors: up, down, strange, charmed, top, and bottom. Very unbelievable, but it's true. Each flavor came in 3 colors: red, green, and blue. Now, these aren't really colors, since the atom itself is smaller than the wavelength of light, so they just don't have any colors. Now, quarks might be the elementary particle, but we don't really know. Since we can't see into the atom in a normal sense, we might be able to use waves that have a shorter length, like gamma rays. Then we might be able to see if there's anything inside the quarks themselves. Now I'm going to talk about something else. It's called spin. All waves and particles can be described as particles because of quantum mechanics. Now, all the particles have a property called spin. Now, if you want to think of spin, imagine a top spinning without a well-defined axis. Now, there are 4 types of spin. The first spin can be described with this ball. It's called spin 0. No matter how many times you spin it, it will always look the same. Now, there's something called spin 1. Spin 1 could be described with this car. To make it look exactly the same, to spin it 1 full rotation. Then the spin 2 can be described by this pyramid. To make it look exactly the same, you have to spin it 1/2 of a rotation, 180 degrees. That's spin 2. Now there's something called spin 1/2, which cannot be described in a normal sense. Spin 1/2 particles, to make them look exactly the same, you have to spin them 2 full rotations. Now, no one really believed that until Paul Dirac made a mathematical theory which proved the existence of these, which it said how it was possible. Now, he also predicted that the electron should have an anti-electron or a positron, which proves that for every single piece of matter in the universe is always a piece of antimatter. Now, all these particles that have spin can be categorized into 2 groups. The first group gives off matter. It's all matter in the universe, and it's made of spin 1/2 particles. Spin 1, 0, and 2, they make up the forces in the universe. Now, because for every single piece of matter there's a piece of antimatter, there could be whole worlds of antimatter and anti-people. But if you come in contact with antimatter, there'll be a huge explosion, and it's not good. Now, force particles are not really existent. They are virtual, and they can be described by this pillow. When I punch this pillow, my fist bounces back and an indent occurs on a pillow. Now it can be described as force-carrying particles. Imagine my fist radiates a force-carrying particle that hits the pillow and pushes it back, creating an indent, and then my fist bounces off. That's a way of imagining a force-carrying particle. But remember, they're virtual, not real. They can be described as waves. There are only 4 types of force-carrying particles. This is man-made, not natural in any way. There's gravity, there's electromagnetism, the weak force, and the strong force. Now, there have been theories to unify the weak force, the strong force, and electromagnetism, but we have not been able to unify gravity. It will be the ultimate goal of physics to unify all 4. That's all for now. Catch you later next time.